ones where we put them into the summation formula, I even struggle with that, and I've been teaching the class for at least 10 years. So that's where you really have to pay attention, because I'm getting just a little bit better on that. Okay, so here's Riemann sum. Let's suppose you want to find the area under this curve. Okay, it's a curve. It's not like we can make, triangles and trapezoids and rectangles and make it fit perfectly. So what we do is we make a bunch of rectangles underneath to approximate the area. Okay, and then here we use 4 rectangles, and you see how much area we missed. So if we get more rectangles, we get less area that we miss. If we get even more rectangles, we get even less area that we miss. If we get our rectangles to be little microscopic little rectangles that are straight lines, then we fill the whole area. And that's what this guy Riemann kind of figured out how to do, is find the area under the curve using rectangles. And then when you get smaller and smaller rectangles and more rectangles, then you get more and more, and it goes to a limit. Oh, we're going to tie limits in with this too. Not right now, but later. Okay? So, if you go to the left side, if you build your rectangles off the left side, it's called a left Riemann sum. Building it off the left side. So then you go up until you hit the left side of the rectangle hits the function, and you go across. So you have a width and a height of each rectangle. And I'll show you how to figure out the width and height. Now, if you go to the right side of your rectangle and you draw over and you hit the function, that's a right Riemann sum. Now, if you look at these two, this estimate of this rectangle plus this rectangle plus this rectangle plus this rectangle would be an underestimate of the total sum, because you're covering less area than what is here. This one would be an overestimate of the total sum, okay, because you're covering more area than actually is covered, okay? So, and it's not always right is more area, left is less area. It doesn't work that way, because sometimes graphs go down. So, we're going to look at this one. We're going to use a left Riemann sum to approximate the area on this function using 3 equal subdivisions. Well, look, we're going from 2 to 5, so making 3 equal subdivisions makes good sense. So we're going to go straight across here. Here's our first rectangle. Okay? Now, rectangle number 1 has a width of 1 and a height. If we put a 2 into this function, it has a height of 1/5. What's 1/5 times 1? 1/5. Our second rectangle, we'll go like this. It still has a width of 1. It has a height of 1/7 minus 3, because 3 is where we built it from. So it would be 1/4. What's 1/4 times 1? Well, it's 1/4. And our third rectangle has a width of 1 and a height of, what do you think? 1/3. So it's going to be 1/3. It goes like this, because 1/7 minus 4. You use the function to figure out the height. Okay? So if you take 1/5 plus 1/4 plus 1/3 and get a common denominator, 60 is common denominator. So multiply by 12, so this is 12/60ths, this is 15/60ths, and this is 20/60ths, which is 32/47/60ths. That's the area of those rectangles. Okay? So that's a left Riemann sum for that. Let's find the left Riemann sum for this one. Now this one, you're going to say, why are we doing this? Because it's not even close to the answer. Because we use a left Riemann sum. If we go up until we hit the function, it is right here at 3. So 4 equal subdivisions from 2 to 6. Yeah, each one of these is 1. So 1 times 3, that has an area of 3. We go up to here and hit it. One times 7 is 7. And then left Riemann sum is right here. 1 times 6 is 6. Because I have to go to the left side of my rectangle where it hits the function, not somewhere in between. And then this one where it hits right here is this. It hits it right there. So this one is 4. Well, that gives me 20 for my left Riemann sum. Left Riemann sum. Now, this is the height, this is the width. You see that there's unequal subdivisions. So, if we're using the left Riemann sum, we have to use this height. If it was a right Riemann sum, we would use this one, and this one, and not this one. But oh, look at Mr. Bierschbach made a mistake. It's a right Riemann sum. So we use this one, and this one. And then we use this distance. This is a width. So our first rectangle has a width of 3 and a height of 5. So it's 15. Our second rectangle has a width of 1. From 3 to 4 is 1. And a height of 7. So it's 7. Our third rectangle has a width of 4 and a height of 11, so it's 44. And then we just add these up. 15 plus 7 is 22, plus 44 is 66. Okay, Riemann sums. Not like you've ever touched anything like this before, so Taylor Boothie, I sure hope you paid attention to that.
I did watch this video.
That's good. Okay, good. Okay, overestimation, underestimation. Okay, looking at this. Here's it shaded in perfectly. Now, if we look at this, we want the least to the greatest. What would be the least to the greatest sum? Well, if we use the left Riemann sum, we'd have that, 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 and so on. Is the left Riemann sum going to give me an overestimate or an underestimate? Overestimate. So the left Riemann sum is going to be the greatest. So that's going to go to the bottom. So you're going to go right Riemann sum will give you the least, because that'll be an underestimate, because it'll be like this. It'll be like this. So it'll be a right Riemann sum will be first, the actual area in between, and then the overestimate would be the left Riemann sum. Okay? For this one going up, left Riemann sum would go there, 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 there. So, what's the smallest? Left Riemann sum. And then the middle would be the actual area, and the right would be an overestimate. Okay? So overestimates and underestimates are fairly simple. Now, we don't have a chart to look at. But if this is going up, it would look like this. Okay? If it's going up, it looks like this. So it's left, actual, right. Left, actual, right. Because it's going up. It's constantly increasing. If it goes down, then it's decreasing. So it's continuous and decreasing. It goes like this. So if it goes like that, then it's right is the smallest, then actual, then left. Okay? Overestimates, underestimates, those are pretty easy. Midpoint and trapezoidal sums. Okay. Here it wants a trapezoidal sum with 3 equal subdivisions. Okay. So a trapezoidal sum goes to each endpoint. So if we're 3 equal subdivisions and we're 6 wide, we go 2 wide each. So we want a trapezoid from here to here. Well, it actually makes a triangle, not a trapezoid. Then from here to here makes a trapezoid. And then from here to here makes a trapezoid. Okay? So our first triangular one, okay, is a width of 2 and height of 4. 1/2 of 2 times 4 is 4. Then we have a trapezoid one, where base 1 is 4, base 2 is 6, our width is 2, 1/2 of 2 times 4 plus 6 is 10. Our last one is the same thing, but backwards. So that's 10. So 4 plus 10 plus 10 is 24 for the Riemann sum. That's a trapezoidal sum. So looking at this one, you say, well, Mr. Bierschbach, you already did this. Well, I already did this with a left Riemann sum. Now I'm going to do this with a trapezoidal sum. So there's my first trapezoid. Here's my second trapezoid. Here's my third trapezoid. Obviously, our answer is going to be a lot closer with trapezoidal sums than a left Riemann sum. So my first trapezoid has a width of 1, a base of 1/5, and the other side will be 1/4. So 1/2 of 1 times 1/5 plus 1/4. So 1/5 plus 1/4 is 9/20. So 1/2 of 9/20 is 9/40. Our second trapezoid is 1/4 on this side, 1/3 on this side. 1 is the width, so we go 1/2 of 1 times 1/4 plus 1/3. Add those up, so that's 7/12. So 1/2 of 7/12 is 7/24. And our last one is 1/3 to 1/2 with 1. So it's 1/2 of 1 times 1/3 plus 1/2, which is 5/6. So 1/2 of 5/6, which is 5/12. And if we add these together, we'll get the actual answer. Okay? All right, last one. Midpoint Riemann sum. What's a midpoint Riemann sum? Well, we're dividing this into 3 equal subdivisions. So from here to here, from here to here, from here to here. So the midpoint is where we are right here at 1. So I draw my rectangle like this. That's a midpoint one. Then I draw my rectangle right here. Then I draw my rectangle right here. So my first rectangle is 1 wide and 3 tall, so it's 3. My second rectangle is 1 wide and 1 tall, so it's 1. My third rectangle is 1 wide and 2 tall, so it's 2. So we get 6 for the midpoint Riemann sum. Okay? So that's the basics of Riemann sums. Then we'll get into the advanced after lunch. So, well, let's get to work. So those of you who watched all the videos last time and got caught up, that was good because, you know, this class, we move right along.